Hello and welcome to this new video, and in this video we are now going to focus on how to calculate the distance along circles of longitudes. All right, so let's look at the diagram on the right side here. You would see that we've been given 2 points, point A and point B, and you would see that these 2 points are lying on the longitude NABS. That is the longitude. Now, how can we calculate the distance between point A and B? How can we calculate the distance between point A and point B? So one thing you should put in mind is that point A and B lie on the same longitude. And this is why we are calculating the distance along the circle of longitude. That being said, you would notice that the same points A and B, they are lying on different latitudes. All right? They are lying on different latitudes. Therefore, this tells us that for us to calculate the distance along circle of longitudes, we always have to understand the angular differences, the angular difference between the latitudes where point A is lying and where point B is lying. At this moment, the diagram on the right might not be able to show the latitudes. It's you to visualize the latitudes point A and point B is lying. Allow me to draw the circle of longitude, which is NABS, having the points A and B. Looking at the diagram we have here now is the circle of longitude where point A and B are lying with our angle, which is Z degrees. So now, when you go back to this diagram, we have this distance from A to B, this distance from A to B, which is what we are having here. Okay, so the question or the focus for today is how do we calculate the distance between 2 points or towns along the same longitude? You would agree with me that if you take a good look at from this point A here to this point here, this is known as arc. And you'd agree with me that we did something similar when we were looking at mensuration during our classes. You would agree that we were able to calculate the length of the arc of a sector. So you can see here, I would say is our O, meaning the center of the earth. And so we have A, O, B, forming that angle A or B. Now, if you take a good look at this, you would agree with me that actually what we are having here from A to O to B back to A is a sector that looks something like this, like that. Is a sector. So how do we calculate the length of the arc of a sector? Okay, so now let's get into understanding how we can calculate this distance here. How can we get that distance? So it's a very simple concept which we already did in mensuration. So we are going to say the distance between points A and B is forming an arc, and therefore the formula is going to be arc AB is equal to, so you look at the angle the arc is subtending on the center of the circle, which is Z degrees. That should be over the whole revolution, which is 360 degrees. That should be multiplied by 2, multiplied by the given pi, and multiplied by radius of the earth. You can see that my radius is capital R. This is very important that we are using capital R because the circle that we are dealing with is a greater circle. All the circles formed by lines of longitudes are considered as the greater circle. Therefore, if it is known as the greater circle, then the radius in kilometers, the radius of the Earth is 6,370 kilometers. We talked about this in the previous video. And that also tells us that the radius in nautical miles, the radius of the Earth in nautical miles is going to be 3,437 nautical miles. Put that in mind. This also occurs when we are dealing with the latitude equator. The circle formed by the equator is also known as the greater circle. So if we get back to our formula, we can see that this will be able to give us the length of the arc AB, hence understanding or being able to calculate the distance between the point A and B. The fact that you've calculated the arc, the length of that arc, it means you've calculated the distance between the 2 points A and B. Let's try and look at how we can use this in real problems. The first example here says point A has latitude 20 degrees and longitude 30 degrees east, and point B has latitude 40 degrees south and longitude 30 degrees east. Find the distance between A and B along the meridian of longitude in A, kilometers, B, nautical miles. So the first thing you have to take note here is that point A is lying on longitude 30 degrees east. You can see it here. And point B is lying on longitude 30 degrees east, which tells us that they are lying on the same longitude, but different latitudes, because A is on 20 degrees north and B is on 40 degrees south. What we need to do is understand the angular difference between points A and B before we can begin our calculations. Being able to understand this angle here, that angle there, all right? Now, how can we do that? I'll try and draw the longitude which we have point A and B on, and then we see how we can get the angular difference. So you can see what I've done is simplified the chart to something that is easier readable and easy to understand. Point A and B are lying on the same longitude and they are in the east direction. However, we have been informed that point A is on 20 degrees north and point B is on 40 degrees south. Therefore, you can see that A is lying on latitude 20 degrees. Now, we know this is north. And point B is lying on 40 degrees south. So how do we know the angular difference? The angular difference is going to come from the latitudes. And therefore, to get the angular difference, we are going to add 20 degrees plus 40 degrees. We are adding because we understand that the latitude where A is lying on is heading in the opposite direction to the latitude where B is lying on. B is lying on latitude 40 degrees south and A is lying on latitude 20 degrees north. Therefore, the difference is that it's north-south, meaning we add. Let's get on the adding. So we are going to simply say 20 degrees plus 40 degrees. That is going to give us 60 degrees. 60 degrees. That is the angular difference. Therefore, that is what we are going to use to replace on our angle subtended by the arc on the center of the circle. Arc, now we are calculating the distance for the distance between points A and B. So, let's look at this. Let me just, okay. The arc, let's get the arc AB is equal to x degree. Now we're using z degree over 360 degrees multiplied by 2 multiplied by pi given multiplied by the radius of the earth. So we'll say therefore this is equal to, the z is the angular difference, and we found that the angle difference is 60 degrees. That should be over the full revolution 360 degrees times 2 times the pi given. Now let's look at this. We have been given pi as 3.142. 3.142. So we're going to write 3.142 times. Now let's look at the radius of the earth. So for the first question, it's asking us in kilometers. So in kilometers, we're going to say 6,370. Let's see how we can get the distance between the points. All we have to simply do is multiply 60 times 2 times 3.142 times 6,370, then divided by 360. So let's say 60 over 360 can be simplified as 1 over 6 times, you can see 2 times 3.142, that is going to be 6.284 times 6,370. So that is simply saying 6.284 times 6,370 divided by 6, because 1 times 6.284 times 3, we're going 6,370 will have what we have here on top, divided by the 6 here. Okay, so we can punch on the calculator 6.284 times 6,370 divided by 6. We are going to have 6,000 671.51 kilometers, which can be simplified or rounded off to the nearest hundred as 6,700 kilometers. If you leave your answer here, it's acceptable. If you leave your answer there, it's also acceptable. That is how we are going to calculate the distance between the 2 points in kilometers. Let's now look at how we can calculate in nautical miles. Okay. The same procedure will take place, but this time the radius of Earth is no longer going to be 6,370. Let me change the ink to now show that I'm calculating in nautical miles. So the same calculation will take place, but on radius we will now have 3,437. Therefore, we are going to have 1/6 times, okay, look at that, times 6.284, okay, times 3,437 nautical miles. So we are going to punch this on the calculator. Okay, let's punch. So we're going to have 6.284 times 3,437 over 6. Now if we punch that on a calculator, 6.284 times 3,437 nautical miles divided by 6, we are going to have 3,599.68 nautical miles. This can be rounded off to the nearest hundred as 3,600 nautical miles. Let's try and see if we can try a question from the past paper. Okay, the question here is saying the point K, L, and M are on the surface of the Earth as shown in the diagram below. Take pi, okay, we've been told to take pi here as 3.142, and radius of the Earth is 6,370 kilometers. I'll skip, maybe let me not skip, let me just answer the first question as well. The first question says, find the difference in longitude between points K and L. Point K is here and L is here. The question is saying, find the difference in longitudes. So we can see that K is lying on longitude 30 degrees west and L is lying on longitude 60 degrees east. Therefore, I can tell that they are heading in opposite directions. So this simply tells me that for me to find the difference in longitudes between K and L, I have to add the longitudes, the degree of the longitudes. So therefore, I'm going to simply say 30 degrees plus 60 degrees plus 60 degrees. Therefore, if we say 30 plus 60, we are going to have 90 degrees. So the difference in longitudes between point K and L is 90 degrees. Let's 90 degrees. Let's look at how we can get the second question, because this is our focus for today. Find in kilometers the distance LM. The distance LM. So let's look at the distance they're talking about. L is exactly here and M is here. So meaning we're calculating this distance from there to there. If I was to construct a rough sketch, we'll have something like this. And then we'll have our point L and our point M. So we need to understand their latitudes they are lying on, so that we are able to get the angle or the angular difference before we start our calculations. So the latitude where L is lying on is 50 degrees north. And where the latitude M is lying on is 45 degrees south. So I'm going to say 50 degrees plus 45 degrees. That is going to give me 95 degrees. Therefore, this is what I will use for my angular difference. The angle that the arc LM is forming is subtending an angle on the center of the circle, or the center on the Earth's surface, as 95 degrees. The angle it's subtending on the center of the Earth is 95 degrees. The arc LM is subtending an angle on the center of the Earth, which is 95 degrees. Therefore, we can now say the arc LM is equal to x degrees over 360 degrees multiplied by 2 multiplied by given pi multiplied by radius of the Earth. So then we can simply say, let me do that, make some space for calculation. We can simply say that is equal to the angle, okay, the angle subtended by the arc LM on the center of the Earth is 95 degrees over 360 degrees times 2 times, we have been given the pi to be 3.142. So 3.142, and radius is in kilometers, so meaning it's 6,370 kilometers. So let's get to punch this on the calculator. So what is 95 times 2 times 3.142 times 6,370 divided by 360 degrees? That is going to give us 563.23, which can be rounded off to the nearest kilometer as 10,600 kilometers. And that is how we are going to get the distance between point L and M in respect to longitudes. Let's look at another example. W, X, Y, and Z are 4 points on the surface of the Earth as shown in the diagram below. Take pi as 3.142 and radius as 3,437 nautical miles. This time, the first question is saying, calculate the difference in latitudes between W and Y, which we are going to simply say the difference in latitude W and Y. W is on latitude 80 degrees and Y is lying on latitude 30 degrees. Okay? W is on 80 degrees and Y is lying on latitude 30 degrees. So we are going to simply add 80 degrees plus 30 degrees. Okay, calculate the difference in latitude between W and Y. Between W and Y. So we can see that W is lying on latitude 80 degrees north and Y is lying on latitude 30 degrees south. So we have north-south, meaning to find the difference, we'll simply add. So 80 degrees plus 30 degrees. That is going to give us 110 degrees. Now let's go to the next question. The next question is asking us to calculate the distance in nautical miles between X and Z. So you can see that X is here and Z is there. So, meaning that we need to calculate the angular difference. So how do we get the angular difference? We are going to calculate the angular difference by saying X is lying on 8 degrees north and Z is lying on 30 degrees south. So the angular difference is going to be 80 plus 30, which is going to be 110 degrees. This is the angle being subtended at the center of our earth or our circle by the arc XZ. So meaning that we are going to simply say the arc XZ is equal to X degree, which is the angle subtended at the center by the arc, times 2 times the pi given times radius of the earth. So we're going to say is equal to, we have found the angle as 110 degrees. So 110 degrees over 360 times 2 times pi has been given as 3.142 times the radius of the earth has been given in nautical miles, which is 3437. Let's now calculate that on a calculator. 110 times 2 times 3.142 times 3,437 nautical miles, that divided by 360. What we are going to get is, excuse me, we are simply going to get 6,599 after punching it on the calculator, 0.42 nautical miles, which this can be rounded off to the nearest nautical mile in 100, to the nearest 100 as 6,600 nautical miles. That is how we can get the distance. I hope you've understood the concept on how to calculate the distance along the circles of longitudes. Thank you for watching, and please feel free to ask questions and have a good day.